Hi, this is Thompson again, and this time we're going to go over a combination circuit as shown on the board here behind me. And we're going to start over on the right side and work our way all the way to the left to get total resistance. And then coming back, we're going to go from left to right to give us the various currents and voltages that apply. So the first thing I'll let you copy it down here. You might want to pause the video for a moment to copy it down and try to work it out, and then come back and turn us on again, and I'll be going over how to solve it. So I assume you've had enough time to work the problem out now, and now I'm going to show you how I would do it. Okay, here we go. Out here on the right side, I've got 5K in series with 1K, and that comes out to be 6K ohms. Here, it happens to be in parallel with 30K, which happens to be in parallel with 20K. Now, this resistor is not part of the parallel combination. Consequently, we have to figure him in later. But right now what we're going to do is to solve this, and the way it's done, we'll take 20K, reciprocate, plus 30K, reciprocate, plus 6K, reciprocate. And now the part that people have a tendency to leave off is to, at the very end, say equal, reciprocate, equal. And at this point, you should end up with 4K ohms, if you did it properly, right? Okay, now this resistor hasn't been accounted for yet, has it? We're going to have to add it in. So with this 4K, I add in the other 4K resistor, and we have a total of 8K ohms. And the 8K ohms will go right here, and that is our total resistance. Now, we're going to try to get some other values, and we're going to start off, we worked our way all the way from right to left to get total resistance, and now I'm working my way from right to left to get voltage and current. The first current we're looking at is right here. 8 goes into 24 30 times, so we have 30 milliamps. Okay, that means that 30 milliamps is going to come out of the battery and come around this way and try to get over here to the very end. But we're going to lose some right here, and we're going to lose some right there. And we don't know how much we're losing at this point, but we know that we're starting off with 30 milliamps. Great. Okay, do we also know that we have 30 milliamps returning to the battery through this resistor? Okay, that being said, 4 times 30 will give us 120 volts. 120 volts. If I have 240 total, and I lose 120 volts, that leaves me with 120 volts. So I can easily put together a Kirchhoff's law situation here, where I'm going to start right here with my total voltage, and the sum of the voltages in any loop has to equal the source voltage, right? Sum of the voltages in any loop has to equal source voltage. So here is my first stop in the loop. Here is the second stop in the loop. And since I used up 120 here, how much do I have left for that spot? 120, agreed? 120 and 20 volts here. Now, I can immediately transfer 120 volts over to the next resistor because these two are in parallel. So this is 120 volts. Or I could just do another loop and include it, right? It would have worked either way, either Kirchhoff loop or just saying since voltage is constant and parallel, these two are parallel, they both get the same 120 volts. Either way, works out fine. Now, I have the current here, which in this case would be 6 milliamps. 6 times 20 is 120. Million K cancel. And over here, I have 4 milliamps. 4 times 30, 120, million K cancel. Okay, so at this point on my freeway I have designed here, I have 30 cars on the freeway and 6 of them took the off-ramp right here. That leaves me with 24 milliamps. Now, if I consider that I lost 4 milliamps here, that leaves me with 20 milliamps. And that 20 milliamps is going to go through this resistor and this one because current is constant in series. Hope that makes sense to you. And now the only thing I have left remaining to get done is to get the voltage on these last two resistors. So 1 times 20 is 20 volts. 5 times 20 is 100 volts. And you'll notice that from this point to this point I have 120 volts. From this point going this way to that point, I also have 120 volts. And we just solved that, that particular combination circuit. I'm going to pause it now and we're going to put up a different one and we can walk through that. You can replay this one as many times as you want and go through as many times as you want until you feel like you understand it. Okay, so we'll stop here for the moment. Okay, we have a new problem up here on the board now. And in this case, we've got 3 resistors, 7K, 8K, and 5K going around the end, all the way around the end over here. And we have these 2 resistors in parallel and another resistor up here. And we know we have 20 milliamps. So the first thing we know is because the battery and this resistor are in series, current's constant in series, so I can put 20 milliamps here as well. Now that's as far as I can go. I can't go any further than that until I get our total, right? I need our total. So out here on the end, I have 7 and 8 and 5K, which altogether amounts to 20 K ohms, which happens to be in parallel with 5 K ohms, which happens to be in parallel with 12 K ohms. Okay, if we take our calculators and reciprocate each of these, 12K reciprocate plus 5K reciprocate plus 20K reciprocate, and I say equals reciprocate equals, I should end up with 3K. Now, I've also got 4K. I've also got 4K up here. So if I take the 3K, which I got by processing these, and I add it to the 4K that's up here, I have 7K total, and the 7K ohms would go right here for our total. All right, I'm going to hold up there for a minute, and we're going to go through this little process, how we actually end up with the 3K. We would take 12K ohms and reciprocate that, add the 5K ohms, which once again we reciprocate plus the 20 k ohms out here on the end, which we reciprocate. We reciprocated each one of those. And now at the end, to bring it back, we have to say equals, reciprocate, equals. That'll bring it back because we had three separate resistors. You might say we had the 12K, the 5K, and the 20K, and we reciprocated the 12K. We reciprocate the 5K, and we reciprocate the last one, 20K. And then we add them all together. Well, we haven't brought them back yet. We have to reciprocate it one more time to bring them back. And when we do, we end up with 3K ohms. Now there is a supplemental rule at the end of your day 3 notes that says in parallel, our total is less than the smallest resistor. Is 3K less than the 5K? Certainly is. So we did it right. Okay, and then we add this 4K that's out here on the end, which wasn't even part of my calculation, for a total of 7K ohms. Now that I've got the 7K ohms, I can determine how much voltage I have. 140 volts. Now, how much volts would I have up here on this top one if I have 4K and 20 milliamps? Looks like that would have to be about 80 volts. Okay, now it's time for Kirchhoff to step in and save the day. So we know here we have 140 volts, and I've used up 80. How much do I have left to go on this first resistor here? Or actually second resistor. How much voltage would I have left to go on this one? Well, 140 minus 80 equals 60. 60 volts right there. Okay, now can I transfer the 60 right over here because voltage is constant in parallel? Yeah, I can do that. So this becomes 60 as well. Now I can get the current, can't I? I can get the current. 60 divided by 12 is 5 milliamps. 60 divided by 5 is 12 milliamps. 5 times 12 is the same as 12 times 5, 60 in both cases. Okay, million K cancel. And my 20 milliamps coming through here got to this point and I lost 5 milliamps. Well, I still have 15. That's good. Then I got to this point and I lost 12. Uh-oh, that's a lot. I've still got 3 left, right? And current is constant in series, and that's a little series circuit out there in the end. So we know that the same 3 milliamps goes through all 3 of those resistors. Okay, now I can finish up getting the voltages. And 3 times 7 is 21 volts. And 3 times 8 is 24 volts. And 3 times 5 is 15 volts. And 80 plus 21 plus 24 plus 15 equals 140. 80 and 60 equals 40. 80 and 60 here equals 40. And the 80 and the 21 and the 24 and the 15 also equals this, according to Kirchhoff's current law, voltage law. The current law is the freeway thing. I have 20 cars on the freeway, 5 take an exit. How much I got left? 15. Out of the 15 cars, 12 took the next exit. How many stole on the freeway? 3. And that goes around the end. Now this 3 and this 12 join together for 15, and then it picks up another 5, and that becomes 20 milliamps coming back into the battery. Okay, I have one more of these I'd like to try, and I'm going to pause the computer now so I can put it up on the board and give you a chance to work it out. Okay, we're back, and we're proceeding to solve another problem. Well, you'll notice right away that this one has a catch that's different than anything we've seen so far. We have a 6K and a 4K resistor that together make 10K. But the very first day of school, you might remember we did series circuits. And the series circuits that we did, we had to combine resistors to get the current. We had a VIR box that we used to combine to get the current. And so we're going to do a similar type thing here. We're going to put a VIR box right here that has to do with these two. And we have current, V, I, and R. Okay, we don't know the voltage there yet, and we sure don't know the current, but we know the resistance. When we combined these two, we got 10K. Okay, and that's what we're going to use right down here when we calculate the total resistance. We're going to use 10K instead of 6 and 4 because 6 and 4 just combine as their series resistors into 10. Now we end up with a parallel combination here over on this side of the of this problem with 12K in parallel with 10K in parallel with 7 and 8, which is 15K. 7K plus 8K equals 15K, and that goes right there. Okay, this is pretty good for finding total resistance, not good for much anything else, but it works out really nice for finding total resistance. And if you punch these in, 12K reciprocate plus 10K reciprocate plus 15K reciprocate equals, you'll end up with 4K ohms. Okay, what I haven't taken into consideration yet is the fact that I have a 4K up here and a 1K down here. I better include them too. So I'll put 4K right here and 1K right here. And when I add the three of them together, that gives me 9K ohms, our total. Our total is 9K ohms. It's the 4 that consisted of this plus the 4 plus the 1. Total 9K ohms. Okay, from this point it's pretty easy for us to get the current, and the current comes out to be 15 milliamps. How do we get that? Well, that was I is equal to V over R, which equals 135 over 9K, which equals 15 milliamps. That's how we got that one. Okay. Now, we know that this part here on the end is a series circuit. That's a series circuit. So what's constant in series again? Isn't it the current? Yeah, it's current. 15 milliamps here, 15 milliamps here, and 15 milliamps down here. Great. 1 times 15 is 15 volts. 4 times 15 is 60 volts. And this part is done, that part is done, and we haven't got over to here yet. Well, here I am trying to figure out what I can do with 12K resistance all by itself. Nothing. So what I have to do is use Kirchhoff's voltage loop law, which we learned about already, to figure out what is the voltage right there. Now we can do it if we use Kirchhoff's voltage loop law, which says the sum of the voltages in any loop equals the source voltage. Okay, well I have total 135 volts. And I've used up how much? 75 of it. How much is left? 60 volts. And that must go here, 60 volts. No choice. That's where it has to go, right? In that loop. Okay. Now I can get the value that I need here for current, 5 milliamps. Okay. Now I come to this crazy mess right here. That's 2 resistors. I'm not going to look at it like 2 resistors because that's too hard to figure out. What I'm going to do is look at it as 1 resistor of 10K. Now, how much voltage does that 10K have on it? 60 volts. Okay. Now, that little VIR box out here, do you remember what the purpose was way back, all the way back to Monday? It was to get total current, wasn't it? To get the current, not total current, the current through these 2 resistors. Wasn't that the reason for it? To get the current? I'll put it up here just in case you might have forgot. To get current. Okay, I got the current. If I just take 10K into 60, because I equals V over R, 10K into 60 will give me 6 milliamps. Okay, so this tells me that I have 6 milliamps in this little tiny series circuit I have here. Just in that series circuit. Nothing else, just right there. Okay, so what's constant in that little series circuit? Current. Yeah, current. Okay, so I could take the 6 milliamps, put it here, and the same 6 milliamps and put it there, and multiply these out, and I'll end up here with 36 volts, and down here with 24 volts, for a total of 24 volts, for a total of 60. So from here to here I have 60, but then from here to here I also have 60, correct? Both places I'll have 60 volts total. Okay, that's kind of taken care of now. And it's time for the freeway, which just another way of saying it's time to look at Kirchhoff's current law. Okay, so how much do I have coming out of here? 15 milliamps. And all 15 milliamps goes through that resistor and comes over to here. Well, not all of it. I lost some right here, and I lost some right here, didn't I? How much did I lose here? 5 milliamps. How much did I lose here? 6 milliamps. So 15 minus 5 equals 10 milli. 10 minus 6 equals 4 milli. So this must be 4 milliamps, and this one over here too, because they're in series, 4 milliamps. These two are in series, right? Okay, and now I can finish this thing up and get the voltage. And the voltage here would be 28 volts, and the voltage down here would be 4 times 8 is 32 volts. Okay, this was pretty much like the other ones, except for one thing. It was that little series circuit we had there, which all we had was resistance. We didn't have anything else. But when we combined them into one resistor, and we got the voltage from here to here, we ended up with 60 volts. It would be very easy to calculate the current. And once we got the current, that's the key to the whole thing. Once we got the current, we could put that current here and figure out respectively how much each one has. The top one, 36 volts. The bottom one, 24 volts. But still, did the voltage from here to here change? No, it's still 60, isn't it? Still 60. Okay, that kind of wraps it up for this session. I have hopes that you're able to get things figured out, and we'll have a video conference here soon, and we'll be able to, I'd like each one of you to sign, just to call in and just say hi, and or have a question that I can answer for you. And any problems you want to go over, that should be possibly tomorrow. The video conference should be tomorrow. And something just went blank on my screen, so I suppose it probably did on your screen too. But anyway, I'll be talking to you then, and just sign in and say hi, or if you have a question, let me know. And that way I can kind of get attendance, see who's attending the video conference, and answer a bunch of your questions. I'm sure you're going to have some, and I'll be working problems out. And so if you have any questions between now and then, write them down so we'll be able to talk at the video conference and maybe get all the stuff figured out. That'll be good. All right, I'll see you then. Bye.